I'm Don LaFawn, Professor Don, and this week we are covering two modules. If you have not watched Module 7 yet, go watch that. It's DHCPv4, and it's the basics. You actually should know DHCPv4, at least the basics of it already, and we add a little bit more in-depth configuration and how to troubleshoot it. In this presentation, in Module 8, we're going to cover SLAAC, and we're also going to cover DHCPv6. I'm not going to jump ahead of myself and tell you what it is. I just want to let you know it is more challenging because, of course, you don't know these commands, probably, and because you have to learn both DHCPv4, SLAAC, and DHCPv6. This is probably the most different configurations you're going to learn in any week this semester. Make sure you take good notes, make sure you put it in your tech notebook, and you'll be fine. And rewatch the video, or go watch some more videos online, or ask questions in the help discussion forum when you get stuck. We'll be there to help you out. All right, let me go ahead and share my screen with you. It's over here. And let me drag this guy over here. And let me let's see, I'm sharing the screen and I need to start the presentation. And then I need to drag this over here. This presentation should take a little bit less than an hour to cover. So we definitely will be done by 8:30, hopefully a little bit before then. All right, so we're learning Module 8, DHCPv6 and SLAAC, and let's get started. So first we'll talk about how we're going to configure dynamic addresses allocation in the IPv6 network. So we'll talk about global unicast address assignment, and we'll explain how IPv6 hosts can acquire its IPv6 configuration. Now SLAAC, it will be explained, and DHCPv6 will be explained, and then we'll configure a DHCPv6 server for both stateful and stateless DHCPv6 configurations. So IPv6 GUI assignment. So if we had a PC, if we're on a PC, we just go to the GUI, and you can configure an IPv6 statically by just typing the IP address in under use the configure IPv6 address. You type in the IPv6 address and the prefix length, and you are home free. Remember, you also have to give it a DNS server address, otherwise your addressing will not leave the network. Then you can go to ipconfig on your host, and you can confirm that it has been issued an IPv6 address. In this case, actually, you're seeing that it has not been issued an address yet. So it needs to go through the steps that we are going to configure. The interface did not create an IPv6 GUI in the output because the network segment did not have a router or IPv6 server to provide network configuration instructions for the host. So this is what we've learned in the past. I'll go in and configure it manually, right? No problem. But if you were to switch and click on the button for obtain an IPv6 address automatically, instead of a manual configuration, and then you don't have an IPv6 router set up to share IPv6 addresses, you are going to get an error message. Now, the # and the number at the end of the local link address is known as a zone ID or scope ID, and it is used for the operating system to allocate the LLA with specific interface. Now, DHCPv6 is defined in RFC 3315, and I just want to add one more thing. Some of you are saying right now, well, heck, you got a local link address there, an FE80 link, but remember, that local link is automatically created as soon as you connect a host to a network. it can only communicate, that address can only communicate within the network. And it is those ICMPv6 advertisements are only used to communicate between the different routers. They can talk between each other using these local, hosts within a network through switches and whatnot. Can talk to each other, but they can't leave the network. We need that IP address to be a global address to be able to get out of the network. Now, IPv6 global unicast address GUI assignment, by default, an IPv6 enabled router periodically sends ICMPv6 router advertisements, which simplify how a host can dynamically create or acquire its IPv6 configuration. Now, there's two different types, stateless and stateful. A host can dynamically be assigned a GUI using stateless or stateful services. Stateless and stateful configuration modes use ICMPv6 router advertisement messages to suggest to the host how to create or acquire its IPv6 configuration. Although host operation systems follow the suggestions of the router advertisement, the actual decision is ultimately up to the host. Now, right off the bat on this page, it can get confusing. So I just want to clarify that stateless, the reason why it's stateless is because if you use either one of these options, no device is tracking the assignment of IPv6 addresses. We'll talk about how the host creates its own IP address, but ultimately that IP address, the IPv6 address, is not actually retained anywhere. It's stateless. There's no tracking of that address. It is verified that it's unique, and I'll tell you how to do that in a little bit, but stateless means there's no list, right? Stateful means that there is a DHCPv6 server that is managing the assignment of IPv6 addresses, and the router advertisement that we'll talk about later. The router advertisement will tell the host to go to a DHCPv6 server to get its address. And then it has to go and get an address from a pool of addresses like DHCPv4. So remember, SLAAC is stateless, right? And DHCPv6 is like DHCPv4, where somebody is tracking the addresses. The IPv4, we don't talk about it as stateful, but IPv4 is stateful in that somebody is tracking the IP addresses and reallocating them and dropping them back into the pool, and all of that is managed by a router or a server that is acting as a DHCP server. Same thing here. Stateful means that it is being managed. Stateless means it is not being managed. It is not being directly managed with a pool of addresses. All right, let's keep going. We talk about each one of these. So how does a router obtain an IPv6? Oh, I'm sorry, it's not GUI. It's not GUI. Darn it, it's not GUI. It's GUA. GUA is Global Unicast Address. Global Unicast Address. Man, I hate that. I even typed it in here. Global Unicast Address. GU. This is wrong. That's what was confusing. I'm going to fix this. Hang on a second. I apologize for that. Let me stop my recording. Pause that so I can fix this because that's not right. Resume. All right. So I apologize for that. I had GUI, G-U-I. I've been a Windows person since the 80s. So that was probably a typo I made. But I'm going to blame them. No, okay. So it's GUA, Global Unicast Address. That means an address. Remember, IPv6 addresses, they generally don't use private addresses, although you can ultimately have private addressing. It's not used for the same purpose that it's used in IPv4. So when you create an IPv6 address, it is globally addressable, and we call that a GUA, or a global unicast addressing. Anyway, so I appreciate that. Hopefully I didn't confuse anybody with that typo. So here we are. So there are 3 router advertisement messages. How a client obtains an IPv6 global unicast address depends on the settings in the router advertisement message. An ICMP v6 router advertisement messages includes the following 3 flags. The A flag. The A flag indicates that the address auto configuration signifies that to use stateless addressing, auto configuration SLAAC to create an IPv6 address. Basically, everything is automatic. A is automatic, auto configuration automatic, whatever you want to remember it. But that's the A flag. The O flag means the other configuration flag signifies the additional information is obtainable from the stateless DHCPv6 server. So the host is going to use some of the information it gets from the router to be able to create its own address, but then the host is then going to reach out to a server, and I'll show a picture of that in a moment, and the server is going to give it things like its domain and DNF server and the other information that we learned in IPv4, same thing. And then the M. Now, M is managed. These letters are really easy to remember. A is automatic. It stands for auto configuration. O is other. It means some is going to come from the router and the rest is going to come from the other configuration is going to come from the DHCP server. And then the M means that it is stateful and everything is managed by the DHCPv6 server. So those flags are important. Now, how they look, and I can't zoom in, I apologize, because this is the last week I'm using my laptop. My motherboard came in. I'm very excited about that. And maybe tomorrow I'll be putting my computer back together. And I'm very thrilled about that. And we won't have this massive mess on my desk right now to be able to do what I'm even doing. So anyway, so here the PC1 comes online. The host comes online. It says, hey, I need we're talking about IPv6. So it doesn't just put a global code saying I need an IP address. Instead, it says I need an router advertisement from a router, from R1. So R1 gets the signal. Now, our R1 replies with these flags. Now, if just the A flag is set, if the A flag is set, these other 2 would never be set if the A flag is set. If the A flag is set, it says, hey, here's everything you need. Go make your address. And I'll show you how you make your address on your own in a little bit using using your MAC address and some other information I'll show you in a little bit. Here, the O flag is set and the A, meaning that you're going to use some of it's going to be automatic and some of it's going to be other. You're going to get that from the router. I guess the other could be set. And then here, for managed, only the manage is set because none of it is automatic, right? So if you see managed, this is stateful, and it means everything is going to be from the server. So the router just says, hey, I can't help you here. This is a stateful network. You need to get your address from a pool that's handled by the DHCP6 server. All right, let's keep moving. So let's talk in depth about SLAAC first. That's the auto configuration. So SLAAC is the default on Cisco routers. Both the M flag and the O flag are set to 0 in the router advertisement. This operation instructs the client to use information in the router advertisement message only. The router advertisement message contains all of the address information I need. There is no other information available from the DHCP server. So what happens is the first step, the router solicitation goes from PC1. It goes to the router. The router responds with the M flag and the O flag not set. The A flag is set. And then the PC1 knows it's going to be creating its own address. Now, not every network has access to a DHCP server. But every device in an IPv6 network needs a global unicast address. The SLAAC method enables hosts to create their own unique IPv6 global unicast address without the services of a DHCPv6 server. SLAAC is a stateless service, which means there is no server that maintains network address information to know which IPv6 addresses are being used and which ones are available. SLAAC sends periodic ICMP v6 RA messages every 200 seconds, providing addressing and other configuration information for hosts to auto-configure their IPv6 address based on the information in the router advertisement. A host can also send a router solicitation message requesting an RA. So if it's going every 200 seconds, what is that? 6, 12, 18, 24. So it's like 3.5 minutes. So if you plug in a host and it doesn't want to wait 3.5 minutes to get a router advertisement from the local router, then it will actually send out an RA saying, hey, I need a router advertisement. That's a router solicitation message. It's saying, hey, anybody out there got information for me? SLAAC can also be deployed as SLAAC only or SLAAC with DHCPv6. That's when the O flag is enabled. So this is, we're talking now, what they did here was they're giving you a little bit more information. This is still stateless auto configuration. That's what SLAAC stands for. Stateless, SL, auto, address auto configuration. Stateless address auto configuration. That's the only time you see these words next to SLAAC. They just, from this point on, they just give you SLAAC. So anyway, the client throws out a, using FFO2, which is the all routers multicast address. It says, hey, I need a router as a advertisement from the router. And then the router says, here's your prefix length, and other information. So in this case, it's giving everything to it. It's giving the prefix and prefix length, which it will then use to create its own address and other information such as the DNS server, etc. And then it sends, using the FFO2 ::1, all nodes multicast. Now, because ultimately this doesn't have an address yet, so it can't send a unicast address back to it because it doesn't have an address, so it has to send back to all nodes. Now, the command, remember, I've told you this 5 times already, maybe more. The command IPv6 unicast routing enables IPv6 and SLAAC operation on a router. If you do not put in the IPv6 unicast routing command, none of this will work. It won't work. Nothing you put in will work. You'll get all frustrated that you get a 10 on the lab, and it's because you forgot that command. Do not forget that command. As a matter of fact, you should be in a habit of every time you do anything with IPv6, start with IPv6 unicast routing. I know I do. If it's already enabled, it won't hurt a thing. PC1 sends a router solicitation message. It doesn't want to wait the 200 seconds. To the all routers multicast address, which is the FF02:2, FF02:2 is the all routers multicast address. It's saying I need a router advertisement. That's this step here. I need a router advertisement. The router using the all nodes multicast address, which is FFO2::1, it says here's your prefix length, and other information like subnet, domain name, etc. It sends that back. Here's everything you need. And then R1 will respond with a router advertisement message that has the prefix and prefix. Oh, I just read that. PC1 uses this information to create its own IPv6 global unicast address, GUA. It creates this interface using EUI64 or randomly generates it. Now, I'll tell you the difference between EUI64 and random in just a moment. In today's world, it's random. In the old, at the beginning, it used EUI, but I'll show you why that's not a good idea in just a minute. Now, the last step is PC1 must verify the address that it created is unique. And it does this by sending an ICMP-v6 neighbor solicitation message. And this is called basically DAD, duplicate address detection. And the duplicate address detection, basically that's what this is. It sends a multicast address to all addresses saying, hey world, this is my address. And it does that. It sends it out to the world. It sends its own address to the world, and it says, am I out there? And if somebody responds, then it creates another address. If nobody responds, then it knows it has a unique address. Now, so let's see what the actual configuration looks like. So enable config T, make sure you do that IP unicast routing. I'm telling you, somebody in this class is going to get stuck on it. I would even put yellow in it in your tech notebook that you're handwriting, yellow, highlight it, maybe put arrows and stuff at it to make sure you don't forget it. Go to the interface, IPv6 address, and then put in the IPv6 address, and then the prefix length, and then no shutdown. This is what we knew before. This is a basic IPv6 SLAAC configuration, and the example you give here, go into F00 and give it an IP address. Now this is the reason why what they're on right now is they're on the router. They're not on the host. They're just configuring the router to have an interface here. Right? Don't configure, that's just the first step. You have to configure this interface on the router before these guys are going to be able to talk to the router. That's all we've done here. This is the configuration steps, and these are the actual address. We've done this before. This is nothing new, okay? We're just configuring that interface right there. Now the next step, this enables IPv6 routing. If this is not done, the RAs will not be sent. That's what enable IPv6 unicast routing does. That starts the RAs, right? And if you don't have the command IPv6 unicast routing, then those RAs, the router advertisements, are not sent every 200 seconds, and nothing happens in the network because you haven't enabled IPv6 unicast routing. All right, let's see. That's all I was showing you right here. And then I also point out in this diagram, I wish I could zoom in, but in this diagram, each one of these devices, these hosts, each one of them has a MAC address, right? The MAC address is what we are going to use in one of the methods, the EUI64 method. We are going to use the MAC address to create our unique address. So we're going to verify, we go to R1, make sure that is configured with an IPv6 global unicast address and link local address. And then it includes or gives you a local address, which is created automatically. Here is the address you entered. Here's the subnet. And then it joined the FF02::1, which is the all nodes multicast address. Now, the all routers group responds to the IPv6 unicast address FF02::2. Now, if you type show IPv6 interface G001 and then /section joined, and you can see that this router has joined both the any nodes and the all nodes and the all routers group. R1 will now begin to send RA messages every 200 seconds to all IPv6 all nodes multicast addresses. Now, the RA messages from R1 have the following flag set. A = 1 informs the client to use the IPv6 GUI global unicast address prefix in the router advertisement and dynamically create its own interface ID. If the O is set, then it's going to get some of the information from the router advertisement. It's the prefix and the network and the prefix, and it's going to get other information from the server. They're not on that. The the O flag is set to 0. The M flag is set to 0. So it says use additional information from the router advertisement message, like DNS server, MTU size, default gateway, etc. This is what it looks like. And then you can go into your PC on the host and type ipconfig, and you can see that it has been given a IPv6 address, and it created that itself. Now it created that itself, and we'll see in a minute how it did it, but you will see. I'm going to wait till it teaches. The PowerPoint explains how it created it using its MAC address, because it's in its own slide, so there's no reason for me to jump ahead. A router sends router advertisement messages every 200 seconds or when it receives a router solicitation message from a host. IPv6 enabled hosts wishing to obtain an IPv6 address information send an router solicitation. I already said that if it doesn't want to wait the 3.5 minutes. It uses the multicast address FF02::2, which is all routers. The figure illustrates how the host initiates the SLAAC method. So in this case, the host says, "Hey, this is a router solicitation message." Says it right there. Router solicitation. Hey, I need an address, and it sends it to broadcast. It sends it to the broadcast, and then router R1 responds with a router advertisement message. Now, using SLAAC, a host acquires its 64-bit IPv6 subnet information from the router RA and must generate the remaining 64-bit interface ID. Now, it does this in one of two methods. Today, Windows, Linux, and Mac OSs all use the random generation method to create their addresses. The EUI64 method, the host creates an interface ID using its 48-bit MAC address and inserts the hex value FFFE in the middle of the address. Let's see if we can find that address over here. Here it is. Do we see an FFFE? If you do not see an FFFE, then it used the random method. I do not see FFFE anywhere in this address. So this was a random way, randomly created. But if you see FFFE, now you actually know the MAC address of the device. You take the 24 bits on the left of FFFE and the 24 bits on the right of FFFE, and put those two together, remove the FFFE, and then now you have the MAC address, which could be a security issue. That's why we don't use EUI64 anymore. Now, some operating systems default to the randomly generated interface ID instead of the EUI64 method due to privacy concerns. And as I just explained, the MAC address is obvious if you're using EUI64. SLAAC host may use the following duplicate address detection process to ensure that the IPv6 global unicast address is unique. Once it's created, the host sends an ICMP-v6 neighbor solicitation message with a specially constructed solicitation node multicast address containing the last 24 bits of the IPv6 address to the host. If no other devices respond with a neighbor advertisement message, then the address is virtually guaranteed to be unique and can be used by the host. If the neighbor advertisement message received by the host, if a neighbor advertisement is received by the host, then the address is not unique and the host just regenerates randomly a new address. Data is really not required because 64-bit interface ID provides 18 quintillion possibilities. Therefore, the chance of duplicate address is remote. However, the IETF recommends that DAD be used. Therefore, most operating systems perform DAD, not DAD. DAD is duplicate address detection. It'll be easier for you to remember what it is if you don't say DAD. It's duplicate address detection on all ICMP-v6 unique addresses, regardless how the address is configured. 18 quintillion. So the chances of 2 different hosts in the same classroom, for example, picking the same IPv6 address is pretty slim. A lot slimmer than winning the lottery. Now, that is SLAAC. Now, we also have to talk about DHCPv6. Now, DHCPv6 can be either stateless or stateful. It's stateful if the address is this bottom option where the manage flag is set. If only the other flag is set, and whenever the manage flag is not set, this is stateless, this is stateful. So what happens is the router solicitation is sent from the client out to the world. The router responds with, if it's SLAAC only, then it just says, hey, here's everything you need. Use only this router. That's the first option, 00, with a 1 in the A position. The second option, stateless DHCP, SLAAC and DHCPv6, use this router advertisement, but reach out to the server for everything else, okay? So that some of it is going to be created, for example, the address may be created automatically by the device, but go out and get the domain and the DNS server, go to the DHCP server to get that information. That's what the other flag set. Other information is gotten, but not all of it. And then there's stateful, and that's where it's managed. The M flag is set. The other two are not set. And in that case, the router responds with a stateful DHCPv6. It responds with a message just saying, go talk to the DHCPv6 server. It looks like this. So the PC reaches out to the router and says, hey, I need an IPv6 address. The router responds back with a router advertisement, and the PC is then able to create the address completely. That's SLAAC. Now, DHCPv6, that is, it solicits all DHCPs. So the PC reaches out to R1, and R1 comes back with the router advertisement, and the router advertisement with an M flag set. Then it says request information, request unicast. So 3, so PC reaches out to the server, and then 4, the server responds with an advertised unicast message to PC1 saying, here is what you need. And then the PC1 requests or information request back to the server for additional information. And then the DHCPv6 server responds as well. Okay. All right, hopefully that makes sense to you. And again, again, now we break it down a little bit smaller. So this one is stateless DHCPv6. This is where the manage flag is not set, but the O flag is set. The A flag and the O flag are set. So stateless operation, what happens is the PC reaches out to R1 with a router solicitation. R1 responds with the O flag set, but the M flag not set. The A flag is also set, but the important thing is the O flag is set. So now PC1 generates its own address, creates its own address, and then reaches out to the DHCPv6 server and says, hey, I need other information. And the server responds with the information that it needs to be able to complete its addressing. Note that the DHCPv6 server in this mode only provides configuration parameters from the clients. It does not maintain a list of the IP address bindings. That is why it is called stateless. Now, you can, so this is how you enable the O flag, because remember the A flag is the default, right? Automatic is the default. SLAAC is the default, right? So you don't need to configure SLAAC on the device. You just have to give it an IP address and bring it up. So here we are configuring the O flag, and the command to configure the O flag is IPv6 neighbor discovery, that's ND, other configuration flag. You can just type other, or I think you can even just type O and tab. I'm not positive about that, but I'm pretty sure you can type O and tab. And then type end, and then it goes out, and you can go to show IPv6 interface, G001 begin at neighbor discovery, and it will give you the information saying host use stateless auto configuration for addresses, host use DHCP to obtain other information. Okay, so that's how you that's the command. You will definitely want it in your tech notebook. That's the command how you set the other flag. Now, stateful DHCPv6 operation. This is where the M flag is going to be set. So the way this works is the PC1 reaches out to the router. The router says, no, the M flag is set. So you need to get everything from your server. So when the PC receives that, the router advertisement message says it must contact the DHCPv6 server, and it does that. And then the PC and the server are going to chat back and forth to get all of the information the PC1 gets, including the address itself. And again, this is stateful, which means that a list of addresses is maintained by the IPv6 address bindings, and you can see the commands by typing. First they tell you how to set it. So again, you go to the interface. And then again, it's really super easy. IPv6 neighbor discovery. Just gonna remember that neighbor discovery, the ND, right? And don't type neighbor discovery, it won't work. It's ND space manage configuration. I'm pretty sure you could type M tab, and that sets the M flag and end. And then now you can do that same command we did a moment ago to show in your interface, show IPv6 interface. Go look at the interface to see what the flags are set, and begin with neighbor discovery. And then here you can see host use DHCP to obtain routable addressing. Let's go configure DHCP6 server on the router. What we just learned was how it communicates. Now we actually have to go configure some additional steps, including the relay agent. So Cisco iOS routers are powerful devices. In smaller networks, you do not have to have separate devices to have a DHCPv6 client or relay agent. A Cisco iOS router can be configured to provide DHCPv6 server services. So, and it can be either stateless, either configuration, DHCPv6 or SLAAC, or stateful DHCPv6. v6. It can also, the router can also be configured to be a client, just like we did in IPv4. We can set the router to get its address by another router. In this case, we would configure this to be the client, and we would put, guess what, IPv6 DHCP instead of giving it an address. An address? The router here is going to be the DHCPv6 server, and again, it can be in any one of the 3 configuration modes that we've already covered to this point. So let's talk about configuring the router as a stateless. Now this is a stateless DHCP server. So we already set the flag, but there's more to it. Because remember, it has to be able to give some information. For example, it's got to give the domain name. So you have to set the server to have the domain name, which means you have some steps. So the first step is to enable unicast routing absolutely every time. You can do it multiple times just for the heck of it to get into practice. Then configure a DHCPv6 pool, and the command is IPv6 DHCP pool, and then give it a name. It's the same command less the v6 that we had for v4. v4 was IP DHCP pool and then the name. Do the same thing with v6, and then configure and then configure pool parameters, including the DNS server, and then whatever that server address and any other thing you want to put in there, like domain name, for example, and then configure the flag. You see here they are configuring the other flag. Yep. Give you a moment to look at that. And stateless client. Now this is where it is getting its address via it's getting its address here via the client. And I misspoke earlier. It isn't DHCP here. IPv6 address auto configuration is what you have to type. It's the same beginning, IPv6 address instead of IPv4 address, but instead of typing DHCP, you type auto configuration. Auto configuration is a much better command. They should backfit IPv4 with that command. It's so much easier to remember than DHCP. Either one of them are easy to remember. And if you forget it, if you try DHCP there for IPv6 and it doesn't work, just put a question mark there, and auto configuration is one of the few things that you'll get there. You'll also get, obviously, IP address and prefix is one, because you could statically configure this. This is when you want it to auto configure using the DHCP client over here. Verify stateless DHCPv6, show IP DHCP pool, and then you can see what the name of the pool is, and you can see if it's got any active clients. Show running configuration. That command we've seen before. Show IPv6 interfaces, G01, and you can see that its stateless address auto configuration is enabled. Global unicast addresses, one has been assigned. No, nobody's keeping track of it, so it's not going to show you the assigned addresses. That is the prefix that you are going to use, that you are going to send out to the world to auto configure their own addresses. And then it shows the default router, that's the gateway. Here we see to troubleshoot, if there's a problem, you might have to use the debug command, debug IPv6 DHCP detail, and you can see that you'll get commands like this, IPv6 using interface pool, IPv6 stateful. Oh, it's stateful. Look at that. If we're not expecting it to be stateful, we've got a problem, right? And I created a binding. Remember, we got a binding. That means it's also it's stateful because we don't have a record of addressing in stateful. I'm sorry, in stateless, either SLAAC or IPv6 stateless. Okay, don't forget configuring the router as a stateful DHCP server. Now this goes back and looks an awful lot like what we did a moment ago. We have to set the IPv6 unicast routing, do it again and again and again, practice. Then give it a name, the IPv6 DHCP pool, and then you have to, it'll go into interface configuration mode, and then you have to configure the pool parameters. So you have to give it the address prefix and the prefix length, the DNS server address and the domain name, and then there are some optional ones as well. And then configure the interface itself. This binds the pool to the address. So IPv6 DHCP server pool, to give it a name, and then set the ND managed flag, the M flag, so that it knows it has to keep track of addresses. Configuring a router as a stateful DHCP client. Now here's that IPv6 address, and you're setting it right here, and you're saying, hey, we have to enable IPv6. You have to enable IPv6 in this on this side, this network, right? Otherwise, it's not going to work. And then you just say IPv6 address DHCP. That's the address that I thought. Oh, you know what? I was wrong back here. I was correct as I thought, but when I said auto configuration, that's setting the A flag. That's setting the A flag. Let's see if you guys in the chat room were smart and knew that. No, you didn't say anything. You didn't catch it. All right. The brilliant students in my class, they are brilliant, actually. They didn't catch it, but auto configuration, you're setting the A flag here with the auto configuration. Enable address auto configuration. What is the difference between this one and this one? This stateful client, that's a stateful client, and this is a stateless client. Aha, aha. So if you are connecting to a router, I'm sorry, a server, and the server is stateless, and it's letting you create your own address on this interface, then you use IPv6 address auto configuration. That so makes sense with the A flag. But if you are just accepting your address from the server, then this is IPv6 address DHCP saying, just give me an address and I'm not going to do anything. I'm going to wait for you to give me one. All right, so that makes sense. Apologize for that little confusion there. Like I said, there are more commands, and this is probably the more challenging presentation and kind of ultimately stateful, stateless, 3 different configurations. That's not really hard, but then trying to keep them all organized, I'll be honest, it's a little bit challenging. This is where you got to be very thankful that I let you have a tech notebook. But you do need to know when you go into your CCNA exam and you get a job someplace, you're going to need to know these commands. So don't just rely on your notebook. Try to do the best you can to memorize. As I say that, and I've given this presentation at least 9 times, and I still got confused there. It's all right. We figured it out, and I appreciate your patience. Now, verifying stateful DHCPv6, show IPv6 state DHCP pool, And then you can see the pool that's been created. You can see the prefix, and you can see that two are currently in use. You can see the server and the domain name, and you can see there are 2 active clients. Remember, this is stateful, so you will see active clients because it is keeping track of those addresses. You can use the following commands to verify stateful DHCP. You can also go to show IPv6 interface G01, and you can see that you have created, what do we got here? We can, look, we have duplicate address detection is enabled, that there's been 1 duplicate address detection attempt. We can see that it's in groups, and it's up and up, and yeah. Here we can go and we can see the bindings. This is a useful command because we can actually see those addresses. Remember, only stateful keeps track of the addresses. So if you want to see what addresses have been bound, you go to binding. So show IPv6 DHCP. If you forget the word binding, just use the question mark. And here you can see that this is 1 address that has been assigned. And then here's the actual address that's been assigned. Here's the address, and this is the local link. And then here's the address that's been assigned, and it has a preferred lifetime 86,400, valid lifetime set 172,800. I actually have that someplace on a slide that comes up. I think this is it's on the next slide. Let me just go there. That number, the valid range for how long a preferred lifetime, that argument specifies the amount of time in seconds that the specified IPv6 prefix is advertised as being preferred. Valid ranges go from 0 to 4 billion seconds. And I went ahead and Googled that, and that did the calculation, and that's over 100 years. So for the majority of us, that is going to be your lifetime, my lifetime. The maximum value represents infinity, which can also be specified with infinite. The default is 604,800, which is 7 days worth of seconds. That is the maximum value representing infinity. You can type, the default is 604,800, which is 7 days. That's the default IPv6 address. But you generally will find that it has been set to infinity, because there's so many IPv6 addresses, you don't have to worry about it, right? Give a student an address and if he comes on campus once in his lifetime, who cares, right? And give every student that comes online. Give it to every person that goes to a football game and fills the stadium. You could go 100 years of doing that and still not run out of addresses. So don't worry about that. Now, valid lifetime is the length of time in seconds an address remains in the valid state, the time until invalidation. The valid lifetime must be greater than or equal to the preferred lifetime. When the valid lifetime expires, the address becomes invalid. And then I have this, I found that all confusing when I went through this. So I went ahead and found a diagram inside of our content, and I threw this in here just so you can see this is absolutely the same as IPv6, but just different words. So remember, IPv6 has a specific time frame before it has to give up the address and then find another address. Well, in IPv6, it has a preferred address, and then it has a depreciated period of time. So this is the end of the preferred lifetime, and then this is the valid lifetime, which includes both the preferred and this deprecated, that's deprecated, period of time. Now, we also need DHCP relay agents. If the DHCPv6 server is located on a different network than the client, the router can be configured as a DHCPv6 relay agent. The configuration of a DHCPv6 relay agent is similar to the configuration of IPv4 router. Guess what? We put it on, let's see, let's just go to the next slide. We put it on this interface right here to be able to allow this PC to be able to get out of this network to be able to get to this server, right? Here's the DHCPv6 server, and it is outside of this network. This is the Cafe A, this is the Cafe 1 network. That is, well, A being 10, right? And this is 1. And so they're two different networks. And then it's to get out of this network, if this is not the server, the IPv6 server, I mean the DHCPv6 server, then it needs a helper address right there, and then it will be able, the router can then send a unicast message to the server requesting that information on behalf of PC1. Now the command is IPv6 DHCP relay destination, and then whatever that destination address is. Again, use your question marks, right? You know it's a relay, it's IPv6 DHCP relay, put a question mark in there, and it'll be obvious at that point, destination, and then give it an address of the server, right? You're telling it, the router, where the server is, and then to check that, do a show IPv6 DHCP interfaces G0/0, and you will see that that interface is in relay mode. Now, configuring a DHCPv6 relay agent when a local link address is the next hop. The DHCPv6 server address and the egress interfaces are required to reach the server. The egress interface is only required when the next hop address is a local link address. So we talked about this before when we talked about configuring static addresses and having you can either set the interface being the exit interface, the next hop IP, the exit interface, the next hop IP address, or both for a fully specified address. That's all they're saying here. If the next hop IP address is a local link address, you also have to include the, I think we're going the other way. This is the server, that's the relay agent. And there's FE80 0102. I think that's what that says. No, it's 03. And then it's saying if you're going to use this next hop IP address to get to the server, you also have to use the exit interface of G000. And then you can see it written here. You go into this interface and you configure IP DHCP relay destination is this address, this FE80::3, but then you also have to use the exit interface here. Because remember, those local link addresses, the LLAs, those local link addresses can be duplicated. So that the R1 might have 3 different routers, all with an FE80::3. Verifying the DHCPv6 relay agent. The DHCP6 relay agent is operational with the show IPv6 DHCP interface and the show IPv6 DHCP binding command. When you show hang on just a second. So they give you a couple commands here. Show IPv6 DHCP interface. It says that it's in relay mode. You're on R1, right? And then show IPv6 DHCP binding. And then you can see that it is giving you some information about the address and the preferred lifetime. This would be stateful, obviously. And they click over here. And verify the DHCPv6 is working on a host on a host, it is working, I should say. Verify window host receiving IPv6 information with an IPv. You can go to IP config, and then what you see here is the address. Remember earlier I told you you would see FFFE in the middle of the MAC address. So here is 24 bits on the right-hand side, 24 bits on the left-hand side, and that's a 48 bits of a MAC address, and then FFFE in the middle. That's EUI 64. If you want to see if it's EUI 64, look for that FFFE in the middle. Now, there's also something, you also change the second bit by adding, you flip the 7th or 8th bit. I forget what it is. Maybe it's on the next page. No, I don't think so. There's another step you have to flip a bit. And again, we spent a lot of time trying to figure out why you flip that bit. And ultimately, it's just legacy. It was important at the beginning, but it's no longer important other than the fact that we still do it. So you have to do it. So that second bit is the 7th bit. Maybe somebody can put that in the chat room. Is flipped, but the tip off is the FFFE in the middle. Okay, then you know then it used the EUI 64 method. Now again, just a quick summary. Remember, we're talking about dynamic global unicast address assignments. There's 2 different ways: stateless, where nobody tracks the address, and then stateful. Now, when you go to stateless, there's 2 different stateless options. We have SLAAC only, where the router advertisement has all of the information you need. And then there's the other flag is set, and that's where SLAAC also needs the DHCP server to give some of the information. So the address is created using random or the EUI 64, and then the rest of it, things like the domain name and the DNS server and stuff, is given to you by the stateless DHCPv6 server. And again, that's the O flag set. Stateful, it only has one option, and that is a DHCP version 6. That's the M flag is set, and everything is handed down to a host that's coming online. Everything is handed down by the DHCP server. So hopefully that's somewhat clear. And that's it. That's what we've been talking about for the last hour and 5 minutes. You're going to do a lab on this, configuring DHCPv6 on in NetLab, and you'll get a chance to play with all of these. And that is my presentation for Module 8. So hopefully you're not too confused. It is challenging. I told you up front, not too difficult. Make sure you have good notes on your tech handbook, which way to use the flags, how to set the flags, etc. And that will help you to make your commands, your configuration commands, and answer all those multiple choice questions that you know are coming your way, right? So that is my presentation for tonight. Thank you for your patience. I appreciate it. As I said, we'd be done by 8:30. I got 5 more minutes to wrap this up, but I'll be kind. I'll wrap it up right now. My name is Don LaFon. If you got any questions, ask those questions inside of our help discussion forum, and your fellow students and I will help you with those. And if you're live with me now and you have a question, by all means, ask that question now, but not you that are watching me on recordings. I'm going to stop the presentation. So have a great evening, and I'll see you in a week. Oh, actually, I'll see you in 2 weeks, because next week is spring break. Yay! If you're in 2021 spring, next week is my favorite week of the semester. Anyways, have a great week and a great spring break. Thank you.